Okay, so on question 10, they're saying find the domain and the range of the following functions. Hence, sketch the graph of each of the following, showing clearly the x-intercept, okay, the y-intercept, and their asymptotes, if any. Okay, so to make our questions simple here, we're first of all going to sketch, okay, and then from the sketch, we're going to be getting our domain and our what? Our range. Okay, so the first one there, so I'll be stating what type of function each one of these is. Okay, so the first one here, this one here is just a linear function. Okay, so to sketch a linear function, you only need three, uh, 3 points. Okay, we only need 3 points. So we're going to come up with a table of values. So this is the simplest of all of these that we're going to sketch. Okay, so we're just going to come up with a table of values like this to sketch a linear function. So how do you identify a linear function? The highest power on the x should be 1. So we see here that the highest power of this x is 1. No wonder we're saying it's a linear. So I'm going to say x and then f of x. So this f of x here is the same as y. Okay, so I'm just going to pick 3 points. So I should pick 0 and then 1 positive and 1 negative. So in this case, I'll just pick -1 and +1. Okay, and then using this function, I'll find the corresponding values here. So if my x is -1, okay, then I'll have 2 -1 -3. This will be -2 -3. So this will be minus what? 5. So I'll put -5 here. Okay, if my x is 0, to be 2 multiplied by 0 -3, this will just be -3. So I put -3. And then if f of x is 1, then it will be 2, 1, -3. This will just be 2 -3. That will be -1. So I put -1. And then I just plot those points, okay, to sketch this guy. And then from the sketch, you're going to see how easy it is to pick the domain and the range, okay? Because if you just start finding the domain and the range out of nowhere, okay, it will be very cumbersome, to be difficult. So let's sketch this thing. Okay, let's sketch this thing. So I see that I have y-axis, okay, and then the x there. So I'm going to say this is my y-axis, and then this is my x. So on the x, I have 0, -1, and a 1, okay? And then on the y-axis, okay, I can say this is 1, 2, and then going down, I have -1, -2, -3, -4, -5, -6. So let's just plot the points that we can see. So -1, comma, -5, it will be a point that will be there. 0, comma, -3, it will be there. 1, comma, -1, it will be somewhere there. Okay, and then we just join these 3 points with a straight line. So that's what we are going to do. So I'm going to say, let's join these 3 points with a straight line. Okay, so this line that I've drawn here is our sketch for this linear function here. Okay, so you can label it, you say f of x is actually equals to 2x minus 3. Okay, and then from this sketch, we can easily get our domain. Okay, so our domain, we know that our domain are the x values that we can import into this function, right? Okay, and then the range will be the output values that can come out from this function. So from this straight line, I can see that as I go to the left, okay, in the x direction, I go to -infinity. As I go to the right, because this line will continue going, we have just drawn a part of it, I go to +infinity. What about in the y? So as this thing is going to the left, it's also increasing in height, okay? So it goes to +infinity. As it is coming down here, it goes to what? -infinity. So it means the domain, okay, will be a set of all real numbers, or you can write -infinity all the way to +infinity from this sketch here. Okay, the range will still be the set of all real numbers because it's from -infinity all the way to +infinity. Okay, so that's the domain and that's the range for that guy. Okay, so if there are any questions, please feel free to ask. Otherwise, I'll move to part B. Okay, so part B now is uh okay, part B now is uh that's a rational function. Okay, so let's erase this. So part B is a rational function. So how do you sketch a rational function? You just have to find 3 things. 1, the horizontal asymptote. 2, you find what you call as the vertical asymptote. And then 3, you find the y-intercept. Okay, once you find these 3 things, then you can sketch a rational function. So a rational function just simply means it's a fraction. Okay, so here you can see 3x minus 3 over 2x plus 4. That is in form of a what? Of a fraction. No wonder we're calling it as a rational function. Okay, so now to find the horizontal asymptote, Okay, let's write a function here. F of x is equals to 3x minus 3 over 2x plus 4. So to find the horizontal asymptote, okay, so horizontal asymptote. Horizontal asymptote is equals to y is equals to, okay, the x coordinate, I mean the the coefficient of the x, which is on top here. So we have 3x here. So the coefficient of this x is what? 3. Then I divide by the coefficient of x in the denominator, which is just 2. So this 3 over 2 will be our vertical, will be our horizontal asymptote, sorry. So this is like 1.5. So we found our horizontal asymptote here to be 1.5, or simply 3 over 2. So that's how you always find your horizontal asymptote, okay? You just take the coefficient of the x in the numerator divided by the coefficient of the x in the denominator. Okay, you find your horizontal asymptote. And then to find our vertical asymptote, we're going to get whatever is in the denominator here, okay, equate it to 0 and then solve for x. So it will be 2x plus 4 is equals to 0. Okay, and then this will be 2x is equals to minus 4. And then I divide by 2. Even this side I divide by 2. So x will be equals to what? Minus 2. So this x is equals to minus 2 will be our vertical asymptote. Okay, so you write here. So always, to find the vertical asymptote, equate whatever is in the denominator to 0, so for x. To find the horizontal asymptote, get the coefficient of x in the numerator, divide by the coefficient of x in the what? In the denominator. Okay, and then to find the y-intercept now. So if you're finding the y-intercept, then your x is just what? 0. So we're just going to find f of 0 in this equation here to find the y-intercept. Okay, so what will be f of 0? So y-intercept is equals to f of 0, which is equals to 3, 0, minus 3 over 2, 0, plus 4. Okay, so this will just give me minus 4 over, minus 3 over 4, which is approximately what? So 3 divided by 4, which is approximately minus 0.5. Okay, so the y-intercept here, okay, you find it as 0, comma, minus 0.7 what? 5. Okay, so that is what we have. So once we have the vertical asymptote, horizontal asymptote, and the y-intercept, then we can sketch this what? This rational function. Okay, so let's draw up our axis. Okay, so I'm going to say this is my y, then this is my x. Okay, x, y. So let's plot the asymptotes. Okay, so the first asymptote, uh, we can consider this, maybe we can first label this our axis. So this is 0. Okay, 1, 2, 3, 4, minus 1, minus 2, and then minus 3, and then minus 4, minus 1, minus 2, minus 3, minus 4, then 1, 2, 3. So let's plot our asymptotes. So I don't know if I mentioned, but an asymptote, okay, is simply a line that the graph will never meet. Okay, it will just go closer and closer to it, but it won't touch it. Okay, so the first one is x is equals to minus 2. So x is equals to minus 2, it will be this asymptote here. So I'll draw a line on x is equals to minus 2. Okay, so that's the vertical asymptote there. And then what's the other vertical asymptote? Y is equals to 1.5. So 1.5 will be between somewhere here, like that. Okay, so that will be my 1.5. So this is y is equals to 1.5, and this is equals to x is equals to minus 2. Okay, and then from there now we plot the y-intercept. So the y-intercept, okay, is at 0, 0, comma negative 0.75. So 0.75 will be somewhere before the minus 1. So it can be somewhere there. Okay, so it simply means that the graph will be coming, okay, closer and closer to this line. And then it's going to pass through this point. Okay, it's going to pass through this point and then it will go like that. So it will be getting closer and closer to this yellow line, but it will never touch it. Even this side, it will be getting closer to this yellow line, but it will never touch it. Okay, so this is just the first part of the curve. So if my first part of the curve is this side, then it means the other one should be to the opposite side. Okay, so it means the other curve should be here like this. So it means this guy will come on closer and closer to this yellow line to never touch it. Even this side will come on closer and closer, but it will never touch it. Okay, so if I found my first curve was, for example, in this part here, then it means the other one should be on the opposite side. So here, okay, we found that the first one was this side. So it means the other one should be on the opposite side there. So this blue curve here is our f of x is equals to 3x minus 3 over 2x plus 4. Okay, so any questions there on the sketching? Okay, so if there are no questions, we can now state the domain. Okay, so the domain, we can sketch it. I mean, we can state
Sorry.
it. Someone
Oh,
has a
sorry.
question?
Yes. So are we supposed to draw the other asymptotes?
Which asymptote?
Um, with the blue line, you drew an arrow. Should we also draw that?
Oh, this one here.
Yes.
No, no, no. I was just stating you here that if the first part of the graph is this side, the other one should be the opposite there. No wonder I drew the other one this side here. So you don't have to draw this apart here.
No, I'm saying, do we have to draw the other part of the asymptotes?
The other part of the graph, this one here in blue.
Yeah.
Yes,
Yes.
you have to draw. When you just draw this one, it
Okay.
won't be a complete graph.
Okay.
All right. Okay, so now let's state the domain from here. Okay, so the domain here, if we state it, it will be what? Okay, the domain here will be, okay, so you just take a look at this graph here. You can see that this one, as it goes here, okay, it can take on any value of x from minus infinity all the way to this value here, minus 2, but the minus 2 is not included. And then again, it starts after the minus 2, it jumps the minus 2 because it's an asymptote here. And then it goes all the way to what? Positive infinity. So it means the domain is from minus infinity all the way to 2, but the 2 we're not including it because this blue curve here, or this blue curve, never meets the minus 2. Okay, so I'm going to say minus 2 curved brackets, and then union. Again, I start after the minus 2. Okay, after the minus 2, I go all the way to positive infinity. So this one here will be our what? Our domain. Or you can just simply say the domain is, okay, a set of all x's, okay, such that x is a real number, but x will never be equal to minus 2. Okay, even this notation is accepted. Okay, and then for the range, just take a look at the height. Okay, so it will be a similar thing. As it comes from down here, this is minus infinity. It will continue increasing until it will just be coming closer and closer to the 1.5, but it will never be 1.5. So it will be minus 1, minus infinity, I mean, all the way to 1.5, but not including the 1.5, and then union. Okay, after the 1.5, you can see again it's increasing. So it will be 1.5 all the way to positive infinity. So this is our what? Our range. Okay, so any questions there? Okay, so if there are no questions, um,
Sir,
yes?
please explain again on how to find the domain and the range.
Okay, so the domain, okay, remember the domain, we are considering x values, right? Okay, and then the range, we are considering which values? The y values. So from this graph that we have drawn here, this blue graph, remember we have two parts of this graph. We have this one, which is very visible because it's big, and then there's this small part here of the graph, okay? So on this first one, we see that this blue curve here, okay, will just be getting closer and closer to this yellow line, which is the x minus 2, but it will never touch it. So for this part, okay, for this blue part here, that is going like that, it means it starts at minus 2, but it never reaches minus 2 all the way to positive infinity. Because as it is moving like this, it is increasing in the what? In the x values. So this thing here continues to go like this until forever. So it goes to positive infinity. So this part of the graph here, in terms of the domain, okay, it is from minus 2 all the way to positive infinity. And then you also do the same for the part of the graph that is on the other side of this vertical asymptote. So this graph here continues to go like this until to minus infinity. Okay. Okay. And then as it comes here, keeps on getting closer and closer to this x is equals to minus 2, but it never reaches it. So that was the part where we said it was minus infinity all the way to minus 2 like this. So this part, I wrote it there. Okay. And then I said union, once I jump this guy here, the vertical asymptote, I start again at a number that will just be slightly above minus 2, and then I'm going to infinity. That's how we got the domain there. Okay. And then for the range, we also do the same. Okay. Now we'll be considering the y values. So this guy, as it goes down here, it goes to minus infinity. And then as it comes up here, it will just be getting closer and closer to this yellow line now, which is 1.5. So we said this part from minus infinity, getting closer to 1.5 was this. And then we unionize this one with the other part of the graph, which is above this horizontal asymptotes. Okay, so this one will be getting closer and closer to 1.5 as well, but it will never touch it. So it will be values that are above, slightly above 1.5, all the way to infinity. As it goes up like that, it goes to positive infinity here. Yeah, what have I done now? Okay, yeah. So have you understood it now?
Yes, sir.
All right, so let's do another question on this same thing so that we get to understand it. Okay, let's do another rational function. So rational function, we can see on C, I have f of x is equals to 1 over x plus 2. So what will be my vertical asymptote? So vertical asymptote, we said we equate the denominator to 0, and then we solve for x. So that will just be a minus 2 as well. So vertical asymptote is minus 2. Okay, what about the horizontal asymptote? So horizontal asymptote, we said we get the x coefficient, the coefficient of x in the numerator. Okay, so here I can't see any x in the numerator. So it means the coefficient there is 0, divided by the coefficient of x in the denominator, which is 1. So this will just give me 0. So horizontal asymptote is y is equals to 0. Okay, once we have the asymptote, we can find the y-intercept now. Okay, so the y-intercept is found when x is equals to 0. So this will just be 1 over 0 plus 2, which will just be half. So the y-intercept is at the point 0, 1 over 2. Okay, so once we have this now, we can sketch our graph. So this is my y. Okay, and then this one here is my x. So I have 0, okay, 1, 2, 3, minus 1, minus 2, minus 3, and then minus 1, minus 2, 1, 2, 3. So let's plot the asymptotes. So the first one is at x is equals to 2. So we draw a straight line here at x is equals to 2. So we draw it like that. Okay. And then where is my other asymptote? It is at y is equals to 0. So y is equals to 0 is just the x-axis. So you're just going to draw a dotted line above the x-axis like this. So indicating that your horizontal asymptote is equals to y is equals to 0. Then your vertical is x is equals to minus 2. Okay. And then now from here, we have to plot this point here, the y-intercept. The y-intercept is 0, half. So 0, half should be somewhere here. Hey, where? 0, half. So half before we reach this one. So 0, half should be somewhere there. Okay, so this simply means your curve comes like this, not touching the blue line, and then goes like that. Again, not touching this dotted blue line. So if one part is here, the other part should be there. Okay, so the other part of the graph will come like this. So we have two parts, this green and that green. Okay, so that's the sketch. The domain, we do the same thing that we did. The domain, we're considering the x values. So this one is coming from minus infinity all the way up to minus 2. So minus infinity all the way to minus 2. And then I jump the minus 2. I start again at a value that is slightly above minus 2. So that would be union minus 2 all the way to positive infinity. So this will be the domain. And then for the range, okay, for the range, I take a look at this graph in the vertical direction or in the y like this. Okay, so as it goes down here, it goes to minus infinity. And then as it comes up here, okay, it ends at y is equals to 0. So it doesn't touch the y is equals to 0. So it means the first part of the range is minus infinity all the way to 0. And then I jump the 0. I start again at a value that is slightly above 0. And then I go to positive infinity as I go up there. So it will be u 0 positive what? Infinity. So that's what I have there. Okay, so that would be my range and that would be my domain. So I'm sure now it's very clear on the rational functions. Okay. Otherwise, we'll go to another type of function, which is very simple to sketch. Okay, it's very simple to sketch. It's called the radical. Okay, so someone has a question?
How do you know when, like, once you found the horizontal asymptote and vertical asymptote, how do you know which direction to draw the graph?
Okay, so the thing that shows you the direction of the graph is this point here, the one I was saying, the y-intercept there. Okay, so when you plot this y-intercept, definitely the graph should pass through there. Have you gotten it? The graph should pass through the y-intercept. Yes. So it's the one that helps us to find the direction. Otherwise, without it, we wouldn't know. If we sketch it here and there or there and there, we wouldn't know. So it's very important to find this y-intercept here. No wonder we are finding it.
Okay, thank you.
Okay, let's look at D. So D is on radical functions. So radical functions simply means square root functions. So to sketch square root functions, we're going to be using transformations. Okay, so those transformations require you to know the standard graph of a radical function. Okay, so the standard graph is f of x is equals to the root of x. So now to this root of x, they can add a lot of things. Okay, they can add +2, -2, they can add whatever. Okay, but as long as you know the sketch of root of x, then it will be very easy for you to sketch the graph of any radical function. Okay, so we just have to know this one. Okay, that the sketch of root of x, okay, if this is my y and then this is my x, is a sketch that starts at 0, 0, and then it goes like that. So this thing that I've drawn here, this is the graph of y is equals to root of x. Okay, so now depending on whatever they have added inside there, this graph will start shifting. Okay, so it can shift to the left, it can shift to the right, it can shift down, it can shift above. Okay, so in general, I'm going to say f of x is equals to, okay, f of x is equals to b plus, okay, root of, let's say x plus or minus c, like this. Okay, so if what you have with the x under the root there is a positive number, then the graph will shift to the left by those units if it's a positive number. Okay, so for example, if it was like this, so let me just separate them. If it was like that, okay, under the root here, we have x plus something, then it means that, okay, this graph will shift to the left by the c units. And then if this is positive here, b, it means the graph will shift up by these b units. Okay, so if I add now, f of x is equals to minus b plus the root of x minus c. This minus c means that it should shift to the right by c units. And then the minus b, it should shift down by b units. Okay, and then what else? We have a scenario where we have a negative in front of this root. So if I have negative of root x maybe, this simply means I reflect, okay, the graph of root x in the x-axis. So if this is the graph of root x there, the graph of minus root x should come like this. So the x-axis is acting like a mirror. Okay, so that's what it means. So those are the few tricks that you need to know, and then you'll be good to go. Okay, so to find the horizontal shift, you just get whatever is under the root there. Okay, you equate it to 0 and then solve for x. So if you get x is equals to a negative number like this, you say the graph shifts to the right, to the left, I mean. If your x is equals to a positive number like that, then your graph shifts to the right. Okay, so that's what we're going to be using there. So now let's look at what we have here. So there we have, okay, f of x is equals to the root of 3x minus 6. Okay, so what we're going to do here is get whatever we have under the root, equate to 0, and then solve for what? For x. So this will be 3x is equals to 6 divided by 3 divided by 3, x is equals to plus 2. So it means this graph here is just the graph of root of x that have been shifted 2 units to the right. So when sketching, okay, you start with a standard one. So this is 0. So the graph of a standard is like that. So this is root x. Okay, and then this unit has been shifted 2 units to the right. So if it started at 0 here, it has shifted to 1 to 2. So it has shifted 2 units to the right here, because here I found x is equals to plus 2. So it means this guy has moved now. It's there. Okay, and then the graph will go like that. So this graph now that I've drawn, that starts at 2 and then it goes like that. It will be the graph of the root of 3x minus what? 2. Okay, and then from there, we can easily get the domain. Okay, so the domain for the x values, we're starting at 2, and then we're going all the way to what? To positive infinity. So the domain there is 2, and this 2 is included in the domain, all the way to positive infinity. Because I'm starting at 2, and then I'm moving like this. Okay, so I'm going to positive infinity. And then the range, okay, what do you think the range is? The range is the lowest y value. So in this x-axis, what is the y? What is the value of x? In this x-axis, what is the value of y? Okay, so the value of y in the x-axis is 0. So it means the range is from 0 all the way to positive infinity. Because as it moves like that, okay, it is increasing in height. So it's going toward positive infinity. But the lowest point is at this point, which is the x-axis. And in the x-axis, the y is 0. So the domain is that one, the range is that one. Okay, so any questions there? Okay, so if there are no questions, let's look at part E. So part E,
Sorry, sure.
Oh, someone has a question?
So don't you have to also stretch the graph by 3
Don't
and
have to
translate it to -6?
the graph of what?
The graph that you drew, don't you have to stretch it by 3 because it's the coefficient is 3. It's 3x.
Oh, it doesn't matter. It doesn't matter unless they tell you to show all the transformations. But here there's that said sketch.
Okay.
Yeah, so the shape won't change, but it's just that when you have a coefficient of 3 in front here, okay, the graph will like it will it will it will compress to the side of the y-axis, and then if you have a fraction there, it will detach from the y-axis like that. But here we're just sketching, okay? So it doesn't matter. We can leave out the stretch there.
And wouldn't you have to shift the graph to like x is equal to 8 because of the -6? So
This
you shift it to the right.
this one,
Yes.
yeah. So you are asking that wouldn't we shift it to 8?
Yes.
No, we can't shift it to 8 because the shift that we found here is +2. So look at this, like what we have in the under the root here is 3x minus 2, right? So to get the horizontal shift, you just get whatever is under the root here, which is 3x minus 2, you equate it to 0, and then you solve for x. So when we solved here, we found that x was +2. So meaning it has shifted to the right by what units? 2 units. So we can't take it to 8, no.
Okay, thank you.
All right. Okay, so we move to the next one, which is what now? We have 2 minus the root of 2x plus 5. Okay, so let's try to sketch that one. Okay, so let's do that. So again, there we're just going to take the stretch for granted, okay, because they didn't mention here, they just said sketch. So a sketch is just a rough presentation of something. So here we have f of x is equals to 2 minus the root of 2x plus 5. Okay, so what I'm going first to sketch here will be the root of x. So the root of x will start at 0 here, and then it will move like that. Okay, to be moving like that. So this is my x, this is my y, and what I've drawn here is just the root of x. Okay, so now I can see a horizontal shift inside there. So I would say 2x plus 5 is equals to 0. This will be the same as 2x is equals to minus 5. Okay, and x is equals to minus 5 over 2, which is just x is equals to minus 2.5. Okay, so what does this mean? It means this graph here has shifted to the left because I found a negative here. So it has shifted to the left by how many units? Minus 2.5 units. Okay, so if this is -1, -2, and then -3. So from this 0, it has come here. Okay, this is the minus 2.5 units. So I shifted to the left here. So now record. Okay, so now that we have found the shift here, we can now sketch, right? So I'll say this is my y, and then this here is my x. So here I have 0, okay? And then somewhere here I have 1, and then 2, 3, and then here I have -1, -2, -3, -4. Okay, and then coming down, I still have -1, -2. Even going up, I have 1, 2, 3, okay? So the first thing, we said we sketch the root of x. So the root of x is this sketch here. Okay, so this is the root of x. Then from the root of x, I'm going to sketch root of 2x plus 5. Okay, so this 2x plus 5, it is just this curve that has been shifted to the left by minus 2.5 what units. So it has now come somewhere here on minus 2.5. Okay, and then now when I draw a sketch, it should pass through some y value here. So how do we find that y value? We say in this thing, okay, let my x be 0. So that will be root of 0 plus 5, which will just be what? The root of 5. So it passes through the root of 5, but the root of 5 is 2 point something. Okay, the root of 5 is 2 point something. So it means this curve passes somewhere there. So it should be 2 point something there. Okay, so that's how it goes. And then this one here will be the root of 2x plus 5. Okay, and then afterwards, I consider now this negative. So I want to sketch now minus 2x plus 5. Okay, so now this makes sense. So it means I'll just reflect it in the y-axis. So this is the root of 5 here. Okay, I just negate this. It will be minus root of 5 somewhere after the -2. So minus root of 5 here. So it will come something like this. Okay, it will come something like that, passing through that point. So this yellow thing here, okay, is minus root of 2x plus 5. Okay. And then from there, what are we going to do? I'm going to move now this graph 2 units above because I have a plus 2 there. So I'm moving it 2 units above. So this one was at y is equals to 0 in the x-axis. It moves to 2, which is somewhere there. Okay. This one was at minus root of 5. So minus root of 5, okay, is approximately minus 2.236. So to that number, we add a 2. Okay. It's going to give me 0.23. So 0.23 will be somewhere there. Okay, so it means this curve now will be this curve here that comes like this. To be this curve that comes like that. Okay, so this curve now is my 2 minus the root of 2x plus 5. So we're just sketching it using what? Transformations. Okay, so from there now we can do what? We can find the domain and the range, unless there are questions, or now we have sketched. Okay, unless there are questions.
Sir,
Someone has a
please
question?
explain on.
Yes. So for the graph, when you're drawing it,
Mhm.
before you find your final answer, shouldn't it be dotted lines?
Yeah, it should be dotted line, but here I'm using different colors. No wonder I can just do a solid line. But for you, you should
Okay.
use dotted lines. Then the final one, this one here, should be the one which is in solid form.
Solid.
Yes.
Okay. Thank you.
Okay. If there was another question.
Sir, can you please explain how you're able to find the final answer? Because I got lost after reflecting 2x plus 5, square root of 2x plus 5.
Okay, so up to this point here, you are okay.
Yes, sir.
Okay. So now we said this here, this curve here, it was the curve for minus 2x plus 5, right? Okay. So now our final curve is 2 plus it's 2 minus this root of 2x plus 5. So it means the graph of this, okay, we're now moving it 2 units going up. That's what this 2 is doing here. Okay. So meaning every point that is noticeable on that Yoka curve that you've drawn, you should move it up by 2 units. So the first noticeable point is this guy here. So this guy is in the x-axis, which is y is equals to 0. So to this 0, you add 2 to this point. It will go where? 0 plus 2, it will go to 2. So because that is 2 there. So this point has moved up by 2 units. Okay, it has gone to 2. And then the other noticeable point is this one here, which is minus root of 5. So to this minus root of 5, okay, I'm moving it 2 units above. So it's like I'm just adding 2 to this. So it will just be minus root of 5 plus 2. So when you do this on your calculator, it gives you approximately, okay, it gives you approximate what? Okay, maybe I did something wrong. So because that is minus root of 5. So you did well to ask this question, and then plus 2. I see. So it gives me a negative. So I got a positive one here. So it gives me a minus 0.236. So this number should be below the 0 and not above there. Okay. So it means our curve should be moving in this way. So I will erase this. Okay. So it means this point, this one which was here, has moved 2 units above and it has gone to minus 0.236. So it will be somewhere there, just below the 0. Okay. And then now you connect a smooth curve like that. Okay, so this is the graph of this. Maybe I should put it in another color. So it will be this curve here, like that. So this is the curve, okay, of 2 minus root of 2x plus 5. Okay, so I think maybe that's why you're not understanding it, because I took the positive answer there. Okay, so is that okay now?
Yes, it's fine, sir.
Okay. Okay, so let's do another one of this same nature. We can see this one here. But this one has a secret because it has a negative x somewhere there. So it will be a bit different the way we handle it, okay? Because there's a reflection about the y that I'm seeing. So remember we said f of x is equals to the root of x is the standard, okay? Is the standard radical function, right? Okay, so when you sketch this, we said we get this curve. This is root of x. Okay, so what happens now if I have f of x is equals to root of minus x? Okay, if I have a negative inside there in front of the x, what happens? Okay, the graph is reflected about the y-axis. Okay, so remember when we had the f of x minus root of x, this was a reflection about the x. So it was coming like this. So this was the minus root of x. So now if I have a negative in front there, okay, it will be a reflection in the y-axis. So it will come like this. So this one here will be the root of minus x like that when you sketch it. Okay, so now we're going to use this because here I can see I have minus 3 plus, and then root of 3 minus 6x. So in front of this x, there's a negative here. No wonder I've now introduced this guy, which just reflects in the y like that. Okay, so that's what we are going to be using there. So let's start. Okay, so the function that we have is f of x is equals to minus 3 plus the root of 3 minus 6x. Okay, so since in front there, okay, in front there I can see a negative, then I'll start by drawing the graph that I'm just from showing you there. So it will go like this. So we're going to get this graph is minus x like that. Okay, and then this one has been shifted now by these units. So I just say 3 minus 6x is equals to 0. Okay, this should be 6x is equals to 3, and x is equals to 3 over 6, which is just what? Half. So this half is a positive number. So it means this graph here, okay, it has been shifted going to the right by half units. So if this is my 1, my 2, minus 1, minus 2, okay, it means this graph has been shifted, okay, to go to the right by how many units? Half. So half will be somewhere here. So it will mean that this curve will go something like this. Okay, it has been shifted by half to the right like this, but it still goes like this. So when it comes like this, okay, it will have a y-intercept here. Okay, it will have a y-intercept here. So careful here, we should not repeat the mistake that we did here. We're going to say this graph here is for the minus root of 2x, right? So what is the graph of 3 minus 6x? Okay, it's just this graph that has been shifted 2 units to the right. So to find the y-intercept here, I'm going to say let my x be equals to 0. So if my x is equals to 0, then my intercept will just be root 3 somewhere there. So this graph will come like this. Here, what am I drawing? It will come like that. I need to draw a smooth curve to come like this. So this yellow in graph now, it is 3 minus 6x. Okay? And then from there, we can now move this graph 3 units going downwards because here I have a minus 3 now. So we move the notable points. Okay, we move the notable points. So what is root of 3 approximately? So if you do on your calculator root of 3, it will be 1.73 somewhere there. Okay, so the notable points in this yellow graph is this point and this point. So we are moving this point and this point 3 units going downwards. Okay, so if this is minus 1, minus 2, and then minus 3, this point here is at y is equals to 0. When I add minus 3 to this point moves to minus 3 like that. Okay, so it has moved this point, and then also this point should move minus 3 units going down. So it's like to this number, I'm just adding a minus 3. Okay, so I get, when I do this number or the root of 3 minus 3, I get approximately 1.267. So this is the number that is below, okay, the 1. So this guy has moved to somewhere there. Okay, so it means the curve now will be this curve here. Okay, did we set the domain for the other one? I think we forgot to do, but you can do it. Okay, so that will be the final graph. So let me draw it in red. So it will be something like this. So this red now, it will be minus 3 plus the root of 3 minus 6x. Okay, so any questions there before we state the domain? Have we all followed how we have sketched this? Okay, so that's the answer there. Okay, we have sketched, and then now let's state the domain and the range. Okay, so the domain are the x values, the range are the y values. So the x values, you can see they're coming from minus infinity here. Okay, minus infinity all the way to this point here. Okay, so what is this point here? This point here is x is equals to half. So it means the domain will be from minus infinity all the way to half. And we're including this half because there's a closed circle here. Okay, so that will be the domain. And then what will be the range? So the range, we are looking at the y values. So the height of this thing. So this thing, okay, it starts from this point here. So this point here is minus 3. And then as it goes like this, it's increasing in height. So it goes to positive infinity. So it means the range is from minus 3 to positive infinity like that. Okay, so any questions there? Okay, so if there are no questions, let's do the last one. Okay, let's do the last one, which is a quadratic function. So in tutorial sheet 3, not this tutorial sheet, you have a lot of questions on how to sketch these quadratic functions. Okay. All right, so I have 2x squared plus 3x minus 2. So how do you sketch a quadratic function? Okay, you find the turning point, you find the x-intercepts, okay, and then you find the y-intercept, and then that will be it. Okay, so how do you find the turning point? We can complete the square on this guy. So f of x is equals to 2x squared plus 3x minus 2. So how do you complete the square here? Okay, so when you are completing the square, I'll emphasize when we'll be solving the other tutorial sheet, okay? But I can say it again here. When you're completing the square, always make sure that the coefficient of x squared is a positive 1, okay? So the way it is here with a 2, we can't complete the square, okay? We can't. So we have to factorize the 2. So I'm going to say 2. If I factorize it from this, I remain with x squared. If I factorize it from here, I'm going to remain with plus 3 over 2x. If I factorize it from here, I'm going to remain with minus 1. So ensure that when you multiply these two with everything that is in the brackets, you get back whatever you had. Okay. All right. So now this has become positive 1. We can complete the square now. So it will be 2. And then completing the square is a very simple method. So just look at what I'll do. I'll say x squared plus 3 over 2x. Okay. And then from here, I'm going to get the coefficient of x. Okay. So you always get the coefficient of x, which is 3 over 2. You divide it by 2, and then you square it. Okay. Get the coefficient of x, divide it by 2, and then square it. So dividing by 2, I have 3 over 2, and then I dividing by 2 is the same as multiplying by half. So that will just be 3 over 4. Okay, and then you square it. So if I divide this 3 over 2 by 2, okay, I'm getting plus 3 over 4 squared. Okay, and then this same thing here, you subtract it from this same equation. So you say minus the same thing. Okay, and then you write whatever is remaining, which is minus 1. Okay, so what we've done there is that we have introduced a special 0. You've seen that this is just 0, right? So we are not changing anything in this equation. Okay, that is just 0, but we're just writing it in a special way. It's like I have 5 minus 5. 5 minus 5 is a 0. This is what we've done there. We've created a special 0. Okay, so once you create a special 0, as long as you've created it correctly, okay, the first 3 terms here form what we call as the perfect square. Okay, they form what we call as a perfect square. So the perfect square is in this form. So if I have x minus 2 squared, and then I expand this to be x squared minus 4x plus 4. So this plus 4 here, I can write it as, okay, that plus 4 there, I can write it as plus minus 2 squared. Okay, so you see that to write a perfect square, okay, in simple terms, we just get the term that is squared and the term that is squared, put them in the brackets and then square them. And then this guy, you just ignore it. So you get x, and then whatever is inside the brackets there, minus 2, and then you square it. So you see that when you expand this, you get this. So that's the technique that we're going to be using on these first 3 terms. We're going to say it's 2, okay, and then this one, I just get the term that is squared x, and then whatever is inside the brackets here, plus 3 over 4, and then I square it. And then this guy, I just ignore it. Okay, and then minus, here I have 3 over 4 squared. So 3 squared, it's 9, over 4 squared, it's 16. And then I have minus 1. Okay, so now let's add this thing here. I hope you're following. Okay, it's a very simple method. Just get used to it. So I have minus 9 over 16, and then minus 1. So minus 1 is the same as minus 16 over 16. Okay, so I'm just making the denominators to be the same. So it will be 16, and then on top there I have minus 9 minus 16. Okay, so that will just be minus 25 like this. Okay, so it means what am I going to have? Okay, I'm going to have this is equals to 2, open bracket, and then x plus 3 over 4 squared minus, okay, 25 over 16 close. Okay, and then from here now I can multiply with these 2. So 2 multiplied by this, I get 2x plus 3 over 4 squared. Okay, and then 2 multiplied by this, I get minus 25 over what? 8. Okay, so this here is the completed square form of the function that we had here. Okay, so from this completed square form, we can get the turning point easily. We can find the intercepts easily. Okay, so I'm going to say f of x in its completed square form is 2 x plus 3 over 4 squared minus 2, 5 over 8. Okay, so from that completed the square form, we can get the turning point. So the turning point is that the x coordinate of a turning point, you just get whatever is in the brackets there, equate it to 0, and then solve for x. So if I say x plus 3 over 4 equate to 0, I'm going to get x is equals to minus 3 over 4. So that becomes the x coordinate of a turning point, and then comma, whatever is outside here, okay, which is just minus 25 over 8. So this becomes our turning point. Then the y-intercept, you just get it from the original function, okay? So this original function, whatever is constant there does not have x is our y-intercept, so minus 2. And then now we are just remaining with the x-intercepts. So to find the x-intercepts, okay, then it means that f of x or y is equals to 0. Okay, f of x or y is equals to 0. So I'll put 0 there. So it will be 0 is equals to 2x plus 3 over 4 squared minus 25 over 8. So I'll take this guy to the other side. So it will be 2x plus 3 over 4 squared is equals to 25 over 8. Okay, and then I divide both sides by 2. So dividing by 2 is the same as multiplying by half. So what I have is x plus 3 over 4 squared is equals to, if I divide this by 2, which is the same as multiplying by half, I'll get 25 over what? 16. Okay, so I take the square root of both sides. I have x plus 3 over 4. So if I take the square root of this, I'll have plus or minus the root of 25 over what? 16. And then from there, it will just be x plus 3 over 4 is equals to plus or minus. The root of 25 is 5. The root of 16 is 4. And then x will just be equals to minus 3 over 4 plus or minus 5 over 4. So meaning 1x is equals to minus 3 plus 5 over 4. Or the other one will be x is equals to minus 3 over 4 minus 5 over 4. So this gives me what? X is equals to, this will be 2 over 4. So that will be half. Okay, and then here it will be minus 3 minus 5, that is minus 8 divided by 4, that is minus 2. So the x-intercepts, okay, are x is equals to minus 2 and x is equals to half. Okay, so we've basically found whatever we need to sketch this quadratic function. We found the turning point, okay, we found the y-intercept. We've also found the x-intercept. So this is my x and this is my y. Okay, and then what else do we have to find there? We have to, we just have to plot these things now. So x intercepts, okay, I have minus 2 somewhere there and a half. So the graph should pass through these 2 points. Okay, and then the y-intercept, okay, the y-intercept minus 2 somewhere there should pass through it. And then this turning point, the minus 3 over 4, what is it approximately in decimal numbers? Minus 3 over 4 is approximately 0.25. And then minus 25 over 8 is approximately minus 3.125. Okay, so the turning point is minus 0.25 divided by, plotted against minus 3.125. So minus 0.25 should be somewhere close to 0 here. And then if this is minus 3, then the minus 0.25 should be somewhere here. Okay, so it means you can now see the shape of our quadratic function, though it won't be perfect, but you can see it. So it will be this curve that comes like that, passes through this point, then it goes like that. So this curve will be our 2x squared plus 3x minus 2. Okay, so that's it there. Unless there are any questions from you guys on how I've sketched this. Okay, are there any questions there? Okay, so if there are no questions there, where's the other question now? Okay, there are no questions there. We can move to question 11. So question 11 is on finding the inverse. Okay, so it's just basically those same things that we had, but now we're just finding their inverses. So this is f of x, the first one, is equals to 2x. Okay, hello?
I have a question.
Oh, let me go back to that screen. Yes, what's the question?
Yeah, so like when finding the turning point,
like the value of y, there is this formula, b squared minus 4x over 4x. Like when I calculated, it gave me positive 25 over 8, not negative 25 over 8.
It gave you a positive 25. Okay, so just look at the quadratic equation that we have here. This one. So this is 2x squared plus 3x minus 2. So look at the value of a. So if the value of a, which is just 2, is greater than 0, then we always say that we have a minimum point. Okay? If this value of a is less than 0, then we have a maximum point. So you are saying it gave you 25 over 8. But if it gives you 25 over 8, it will mean this point should be somewhere here. Okay? So it won't agree with this rule because the a is greater than 0 here. So you should have a minimum point. So check your calculations. I think you've gone wrong somewhere.
All right, thank you very much.
All right. Okay, let's try to find the inverse of these guys. Okay, so let me do this.